There's a second video on GCSE indices, so we're going to take a look at changing the base of a number. So write this number here as a power of a single base number. 36, I would hope most people recognize as 6 squared. 216 is a wee bit harder, but that's actually 6 cubed. If you know your cube numbers up to 10, which you should do, you will know that that is 6 cubed. So I'm going to try and write these numbers all then as a 6 and see if we can get this tidied up. So see if we can follow each step. I'm writing the same thing every time, just in a different format. That's why I can use an equal sign. 6 times 6 cubed, all squared, all over 6 squared cubed. So what have I done here? I've written out the question. Instead of writing the 216, I've written it as 6 cubed. Instead of writing the 36, I've written it as 6 squared. Hope that makes sense. As a single base number, so I've changed everything to 6's. 6 times, what's our rules of indices here? That's 6 to the power of 6 divided by 6 to the power of 6. Some people might be able to see the answer from here straight away, but if not, we'll keep going. 6 times 6 to the power of 6, that's 6 to the 1 effectively, so that's 6 to the power of 7 divided by 6 to the power of 6. If we're dividing two things with the same base, we subtract the powers, so that just gives us 6 to the power of 1 or 6. So this whole thing tidies up then as 6, and again that will be a non-calculator question, and we should be able to work that out and see where it comes from. The only 6 cubed is a wee bit tough at 216, the rest you should all be able to do. 4 to the power of 5, evaluate the following, so that's the same as 4 times 4 times 4 times 4 times 4. You can do this whatever way you want and sort of try and work out your way up, but it's going to be 4 times 4, which is 16, times 4, which is 64, times 4, which is 256, times 4 with them, which is 1024. 0.01 to the power of minus 2. Goodness. Right, so 0.01 I'm going to try and write as a fraction. That's the same as 1 over 100 to the power of minus 2. The minus means it's 1 over, so it's already 1 over, so we're going to bring it back up to the front, and then the 2 means it's squared, so that's just going to be 100 squared. 1,000,000. So the answer to that then is going to be 10,000. 25, we're running a wee bit of space here, we'll just do it down here. So 25 to the power of minus 1. The minus 1 means 1 over. So the answer then is 1 over 25. Next one here then is just very similar to example 1 up above, but there's a wee bit of work required. So I'm going to change everything again. I can see a 36 here, and I'm going to change everything then to the same base. Also, square root, if you know it, this is a tough question, is anything then to the power of a half. That's not necessarily in our course, but we'll follow it through anyway. So I'm rewriting this out then as 6 squared cubed. Do you see what I've done there? So that's the 36, which is 6 squared cubed, multiplied by 6 squared. In fact, you know what, we'll just do the square root of 36, we know is 6. That's a much more straightforward way of doing it. Multiplied by 6 to the power of 4. So do you see what I've done? I've changed this, so 6 squared when it's cubed, times 6 squared, that's okay. The square root of 36 is 6, and then 6 squared squared is 6 to the power of 4. Tidying up then, that gives me 6 to the power of 6, multiplied by 6 squared, all over 6 times 6 to the power of 4. And let's work our way along here. That gives me 6 to the power of 8, because we add the two powers, all over 6 to the power of 1 times 6 to the power of 4 gives me 6 to the power of 5. And that then gives me 6 cubed. It says to evaluate it, so we want the actual number for that, and 6 cubed, if you remember from our first example, then it's 216. Wee bit then on index equations, again quite tough here. You should be able to solve index equations by changing the base and equating the indices. To solve equations involving indices, we need to write each side of the equation as part of the same base number. 4 and 8 look a wee bit kind of awkward there, but if we change them both into 2's, then we can work from there. So we need to change things to the same base, so 2 is the way we're going to go. So I'm going to write my 4 as a 2 squared, all to the power of x, and then write that then as a 2 cubed. Next line, multiply our powers, 2 to the power of 2x, equals 2 to the power 3. Make sure you can follow what I'm doing in each step here. So just change the 4 to a 2 squared, change the 8 to a 2 cubed. That's changing it all to the same base. Here's the move. 2 to the power of something equals 2 to the power of something. That must mean then that these two things must be equal to each other. So our next line we can actually write 2x equals 3. Because this power must be the same as this if the bases are the same. The next then is 3 over 2, or if you want then 1.5. Example 2. Find the value of y if 25 to the power of y plus 1 equals 5y. Again, the same format. We need to change everything to the same base, so I'm going to change this into a 5. Taking things nice and slowly. That's a 5 squared to the power of y plus 1 equals 5 to the power of y. What's our rules in of indices? I multiply this by this, being careful here. 5 to the power of 2y plus 2 equals 5 to the power of y. This is 5 to the power, this is 5 to the power, so I should be able to make the two powers equal to each other. So I then have 2y plus 2 equals y. I would take away y from both sides. If I take away y from both sides, I get y plus 2 equals 0. And then taking away 2 from both sides, I get y equals minus 2. Finally then, example 3, 10 to the power of x, sorry, 1000 to the power of x equals 10. Again, I hope you can see we're going to change everything to base 10. So that's going to be the same as 10 cubed to the power of x equals 10 to the power of 1. Because that's just 10 to the power of 1. 1000 is just 10 cubed. I've changed it to the same base. Using our laws of indices, 10 to the power of 3x equals 10 to the power of 1. That means I can write 3x equals 1 and x equals a third. So the answer here that makes this equation work is a third. The answer that makes this one is minus 2, the one up above, and the value of x that makes this one work is 1.5.